Hi everyone. Today we're doing notes for 8.2, testing the mean mu. So how to test mu when your sigma is known. So x has to be a random variable appropriate to your application. Obtain a simple random sample of size n of x values from which you compute the sample mean x bar. The value of sigma is already known, perhaps from a previous study. If you can assume that x has a normal distribution, then any sample size n will work. If you cannot assume this, then use a sample size n is greater than or equal to 30. So we're going to state our null and alternative hypotheses and our level of significance alpha. Then we're going to calculate our sample test statistic z using the same formula that we talked about previously, x bar minus mu divided by sigma divided by square root of n. Then we're going to do the standard and normal distribution, pick our type of test, and find the p-value. Then we're going to make our conclusion. Remember, if our p-value is less than or equal to alpha, we reject the null hypothesis. If your p-value is greater than alpha, you do not reject the null hypothesis, and then interpret our conclusion. So here's our first example. Sunspots have been observed for many centuries. Records of sunspots from ancient Persian and Chinese astronomers go back thousands of years. Some archaeologists think sunspot activity may somehow be related to prolonged periods of drought in the southwestern United States. Let x be a random variable representing the average number of sunspots observed in a 4-week period. A random sample of 40 such periods from Spanish colonial times gave the following data. Previous studies of sunspot activity during this period indicate that sigma is equal to 35. It is thought that for thousands of years, the mean number of sunspots per 4-week period was about mu is equal to 41. Sunspot activity above this level may or may not be linked to gradual climate change. Do the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41? So we're going to pay attention to the keywords there. And we're going to use alpha is equal to 0.05. So first we have to write our null and alternate hypotheses. So our null hypothesis is going to be mu is equal to 41. Our alternative hypothesis, remember it says, was higher than 41. So we're going to do mu is greater than 41. Next, we have to check our requirements. What distribution do we use for the sample test statistic? Find the sample mean x bar and the value of the sample test statistic. So our sample size is 40, which is greater than or equal to 30. So we can assume that it's approximately normal. And we know our sigma is equal to 35. So we're going to use the standard normal distribution. Okay, if we put all of this data into our calculator, we're going to find that our sample mean is going to be 47.04. And so let's find our sample test statistic. Z is equal to x bar minus mu divided by our sigma divided by root n. So this is going to give us 47.04 minus 41 divided by 35 divided by square root of 40. And so that's going to give us 1.0914. Okay. Now we have to find the p-value of the test statistic. So I want you to find the p-value for C, and then based on the p-value, I would like you to conclude the test. Okay, so if you recall, the p-value, we're finding that our z is greater than 1.0914. So we can do normal CDF 1.0914 up to 10,000, 1. And this is going to give us 0.1375. So now we have to compare this p-value to our alpha. If you recall, our alpha is 0.05. So our p-value is 0.1375, which is greater than our alpha, which is 0.05. So we fail to reject our null hypothesis. All right, interpretation. So we do not have enough evidence to conclude the sunspot activity was higher than 41 during the Spanish colonial period. Okay. We can also do this in our calculator. So I'm going to make a note down here. When we're doing this in our calculator, you can use the z-test. And so when we do the z-test, you're going to do stat, test, and then we're going to do choice 1, which is the z-test. We can put in our data into our L1, okay, and use our data. And then our mu 0, we'd say is 41. Our sigma is 35. We have our list is that L1, and we're going to choose that our mu is greater than our mu 0 when we calculate the test. And then you'll see you end up with the same p-value, same z-test statistic, and so we'll come out with the same conclusion. All right, how to test mu when sigma is unknown. So let x be a random variable appropriate to your application. Obtain a simple random sample of size n of x values from which you compute the sample mean x bar, sample standard deviation s. If you can assume that x has a normal distribution or simply a mound shape and symmetric distribution, then any sample size n will work. If you cannot assume this, then use a sample size n greater than or equal to 30. So again, we're going to state our null and alternate hypotheses and set our level of significance alpha. Then we're going to use our values to compute the t-test statistic. Again, using the formula we talked about previously, x bar minus mu divided by s divided by square root of n, with our degrees of freedom n minus 1. Then we're going to figure out if it's one-tailed, two-tailed, and then we're going to estimate the p-value, use our p-value to make a conclusion, and then interpret that conclusion. So here's our second practice. The drug 6-MP is used to treat leukemia. The following data represent the remission times in weeks for a random sample of 21 patients using 6-MP. Let x be a random variable representing the remission time in weeks for all patients using 6-MP. Assume the x distribution is mound shape and symmetric. A previously used drug treatment had a mean remission time of mu equals 12.5 weeks. Do the data indicate that the mean remission time using the drug 6-MP is different either way from 12.5 weeks? Use alpha equals 0.01. So we know that the distribution is mound shape and symmetric. We have our mu is 12.5. We're checking if it's different either way from 12.5, and we're using alpha is 0.01. So let's write our hypotheses. Our null hypothesis is going to be mu is equal to 12.5. And because we're checking if it's different either way, our alternate hypothesis is going to be mu does not equal 12.5. Okay, for B, it says, what distribution do we use for the sample test statistic x bar? Compute the sample mean, sample standard deviation s, and the corresponding t-value for the test statistic. I would like you to do this, please. Okay, so it's mound shape and symmetric. We do not know sigma, so we're going to use the t-distribution. Okay. All right, so then we also have to calculate sample mean, sample standard deviation, and t-value. So our x bar comes out to be 17.0952. Our S sub x comes out to be 9.9995. And so for t, we have x bar minus mu divided by s divided by root n. So 17.0952 minus 12.5 divided by 9.9995 divided by square root of 21. This is going to come out to 2.1059. All right, next we have to find the p-value. So to find the p-value, remember in this case, it's a two-tailed test because we're looking at not equal to. So we're going to do 2 times the probability that our t is greater than 2.1059. So it's 2 times our t CDF, 2.1059 to 10,000. And then 20 is going to be our degrees of freedom. Okay, so again, this is located, if you do second VARS, choice 6 is the T CDF in your calculator, and you're going to do lower bound, upper bound, and then degrees of freedom. Okay, so this gives us 2 times 0.0240, or if you did it in one step, you get 0.0480. Next, we have to conclude the test, meaning we compare our p-value to alpha. Our alpha from the problem is 0.01. So our p-value, which is 0.0480, is greater than 0.01, which is our alpha. So we fail to reject the null hypothesis. And so to interpret this, we would say we do not have enough evidence to conclude the mean remission time is different than 12.5 weeks. Again, if we're looking to do this strictly in the calculator, in your calculator, this is the t-test, and so you're going to choose stat, test, and then choice 2, which is the t-test. Okay? And we're going to do the t-test in detail for this last one. All right, practice 3. Archaeologists become excited when they find an anomaly in discovering artifacts. The anomaly may or may not indicate a new trading region or a new method of craftsmanship. Suppose the lengths of projectile points or arrowheads at a certain archaeological site have a mean length mu equals 2.6 centimeters. A random sample of 61 recently discovered projectile points in an adjacent cliff dwelling has a sample mean length x bar equals 2.92 centimeters and a sample standard deviation s equals 0.85. Where x is a random variable that represents the lengths in centimeters of all projectile points found at the adjacent cliff dwelling site. Do these data indicate that the mean length of projectile points in the adjacent cliff dwelling is longer than 2.6 centimeters? Use a 1% level of significance. All right, so for this one, I want you to start by writing the null hypothesis, alternate hypothesis, and your alpha. Please do that. Okay, your null hypothesis is mu is equal to 2.6. Your alternate hypothesis is mu is greater than 2.6, and our alpha is 0.01. Next, we have to check the requirements. What sampling distribution should you use for X bar? What is the t-value of the sample test statistic? So I want you actually to do B, C, which is finding the p-value, and then D, making a conclusion. I want you to do B, C, and D together. And we can do this all in the calculator using your t-test. So go ahead and do that, please. Okay, so using the t-test, we're going to set our mu 0 equal to 2.6. Our X bar is equal to 2.92. Your S is equal to 0.85. Our sample size N is 61. And we're going to choose that mu is greater than mu 0 based on our alternate hypothesis. Okay, so for B, our N is equal to 61, which is greater than or equal to 30. So it's approximately normal. We have no sigma, so we're going to use the t distribution. And then using our calculator, our t is 2.9403. The p-value, running the test in our calculator, is 0.0023. So then to compare this to alpha, our p-value is 0.0023, which is less than or equal to 0.01, which is our alpha. So we reject our null hypothesis. All right, so let's do the interpretation together. So to interpret this, we would say we have enough evidence to conclude that the mean length of projectile points in the adjacent cliff dwelling is longer than 2.6 centimeters. So what follows here is just a description of, again, how to do this in the calculator, which we went over. We'll go over this in detail in class as well. Okay, one more thing I want to go over just to help you with making conclusions. I'm going to add an extra little note in here. So when you're concluding, if your p-value is less than or equal to alpha, then you reject the null hypothesis, and then you say we have enough evidence to conclude your H1, which is your alternate hypothesis. If your p-value is greater than alpha, then you fail to reject the null hypothesis. And then you would say we do not have enough evidence to conclude the alternative. So again, if you reject the null hypothesis, you have enough evidence to conclude the alternate. If you fail to reject the null hypothesis, you do not have enough evidence to conclude the alternate. In the case of these problems, you always state them in context. And that's where we're going to end today.